Hello, math pips! If you've ever felt that logarithmic equations are like a locked door, you're in the right place. Today, we're grabbing the keys to unlock these equations and make sense of each step along the way. Together, we'll go through the rules, spot the common traps, and break down each type of problem you might encounter. So stick around. By the end of this video, you'll be solving them with confidence. Let's start! Example number 1. Solve logarithm of 2x minus 2 to the base 2 equals logarithm of x plus 5 to the base 2. So here we're applying the one-to-one property of logarithmic functions that if the two y's are equal, then the two x's are also equal, the corresponding x's. Okay, so if both the logarithms here are equal, then this 2x minus 2 and the x plus 5 must also be equal. So 2x minus 2 equals x plus 5. Then we apply addition property of equality. So x will be put to the left and negative 2 to the right. So you will have 2x minus x equals 5 plus 2. 2x minus x is x and 5 plus 2 is 7. So x is 7. Okay, before you conclude that the final answer is 7, you have to substitute it first to the original equation. So you will have 2 times 7 minus 2. Logarithm of that to the base 2, is that equal to the right side? So you will have logarithm of 2 times 7 is 14 minus 2, that's 12 to the base 2. On the right, you will have 7 plus 5, that's 12. So logarithm of 12 also to the base 2. So the answer is x equals 7. So the solution to the logarithmic equation is x equals 7. So very simple. You just equate what's inside the logarithm symbol. Of course, we have to make sure that the bases are the same. Another similar example. Example number 2. Logarithm of 4x minus 5 to the base 4 equals logarithm of x plus 1 to the base 4. Same process. The two logarithms are equal if 4x minus 5 and x plus 1 are also equal. Use addition property of equality to transfer x to the left and negative 5 to the right. You will have 4x minus x equals positive 1 plus 5. 4x minus x is 3x. 1 plus 5 is 6. Divide both sides by 3. You will get x equals 2. And then substitute 2 to the original equation. You will have logarithm of 4 times 2 minus 5, is that equal to the logarithm of 2 plus 1? Yes, they're both logarithm of 3 to the base 4. 4 times 2 minus 5 is 3. 2 plus 1 is also 3. So we have logarithm of 3 to the base 4 equal to logarithm of 3 to the base 4. Meaning to say, x equals 2 can satisfy the given logarithmic equation. Example number 3. Solve logarithm of x minus 7 to the base 3 equals logarithm of 1 minus x to the base 3. Similar process. So you will have x minus 7 equals 1 minus x. You will have x plus x equals 1 plus 7. 2x equals 8. Divide both sides by 2. X equals 4. If we substitute 4 to the given, then we will have logarithm of 4 minus 7. Is that equal to the logarithm of 1 minus 4? They're both logarithm of negative 3, but logarithm of a negative number is not defined in the set of real numbers. So we can conclude here that there is no solution. There is no real number x that can satisfy the given equation. So we have to be careful that if we get a certain value x, we don't end there. We should always check if it satisfies the given equation. Like that, we can have the logarithm of a negative number, but that is not defined, so it will not satisfy the equation. Example number 4, logarithm of x plus 11 to the base 6 equals logarithm of 2x plus 18 to the base 6. So same, x plus 11 equals 2x minus 8 plus 18. Put 2x to the left, put 11 to the right. That will give you x minus 2x equals positive 18 minus 11. So negative x equals 7. Divide both sides by negative 1. You will get x equals negative 7. And then substitute. So you will have logarithm of negative 7 plus 11. Is that equal to the logarithm of 2 times negative 7 plus 18? Yes. Negative 7 plus 11 is 4. Take note that it is 4. Logarithm of 4 is defined. And then 2 times negative 7 is negative 14 plus 18. That's also 4. So logarithm of 4 to the base 6 is defined. So we can, our final answer here will be x equals negative 7. Example number 5. Logarithm of x squared plus 6 to the base 8 equals logarithm of 5x plus 2 to the base 8. So we're expecting here a quadratic equation because we have a square here on x. So we have x squared plus 6 equals 5x plus 2. And this is a quadratic equation. So if we're solving a quadratic equation, we can put everything on one side of the equation and 0 on the other side so that we will try if we can factor. Or if not, then we can use the other ways of solving quadratic equations. Okay, so x squared plus 6 will still be on the left. Transfer 5x and 2, that will be negative 5x minus 2. And then 0 will be left on the right side. And then we can combine like terms. Copy x squared and negative 5x. 6 plus negative 2 is positive 4. And then we can factor this. X minus 4, x minus 1. So you have to review your factoring techniques, your lesson in grade 8, so that you can easily factor quadratic trinomials. So you're looking here for factors of positive 4 that will give you a sum of negative 5. So the answers are negative 4 and negative 1. So the product of x minus 4 and x minus 1 is 0 if x minus 4 is 0 or x minus 1 is 0. X minus 4 is 0 if x is 4. X minus 1 is 0 if x is 1. And before we conclude that the answers are 4 and 1, we have to substitute first to the given. So if we will substitute 4, we will have logarithm of 22 to the base 8, both sides. And then if we will substitute 1, we will have logarithm of 7 on both sides. So we have two answers here. We have positive 1 or positive 4. So there are two values of x that can satisfy the given logarithmic equation, 1 and 4. Example number 6. So we have here logarithm of x squared plus 4x equals logarithm of 3x plus 6. Same process. And then we will have quadratic equation. 4x minus 3x is positive x. Copy x squared plus x. Copy minus 6 equals 0. Factors. Factors of negative 6 that will give you a sum of positive 1. That will be positive 3 and negative 2. So x plus 3 times x minus 2 equals 0. That will give us x plus 3 equals 0 or x minus 2 equals 0. And then put 3 to the other side, it will be negative 3. Put negative 2 to the other side, that will be positive 2. So we have negative 3 and 2. Let us check if they will both satisfy the given equation. If it's negative 3, we will have logarithm of negative 3, which is not defined in the set of real numbers. So negative 3 is not a solution. How about 2? So if x is 2, we will have logarithm of 12 on both sides. So only x equals 2 is the answer. So x equals 2. X equals negative 3 is not a solution. Only x equals 2. So here it's very important that you will substitute your answers, the answers that you obtained, to the original equation, because like here we got two answers but actually only one can satisfy because the other one will give us the logarithm of a negative number, which is not defined. Okay, so we have here four items for exercises similar to the given examples. Okay, pause the video to have more time in answering this. And let me take this moment to say a huge thank you to all my subscribers. And for those who have not yet subscribed, please click the subscribe button. I hope to see you also in the comments for your questions and your learnings in this video. If you're new here, be sure to hit that subscribe button and join our community. And to my loyal followers, subscribers, thank you so much for being part of this journey. Let's keep learning together. Okay, let's answer these four items. Okay, so logarithm of 4x minus 2 equals logarithm of x plus 7. 4x minus 2 equals x plus 7. Put x to the left, put negative 2 to the right. You will have 4x minus x equals 7 plus 2. 4x minus x is 3x. 7 plus 2 is 9. Divide both sides by 3. You will get x equals 3. And if you substitute that to the original equation, you will satisfy the given. So x equals 3 is the solution. Number 2, x minus 2 equals 3x plus 6. Put 3x to the left, that will be negative 3x. Put negative 2 to the right, that will be positive 2. X minus 3x is negative 2x. 6 plus 2 is 8. Divide both sides by negative 2, you will get x equals negative 4. And then substitute. You will have logarithm of negative 4 minus 2. That's logarithm of negative 6, which is not defined. So there is no solution in number 2 because you will have logarithm of a negative number, which is not defined. Number 3, we will have 2x plus 2 equals 4x minus 1. So we will have 2x minus 4x equals negative 1 minus 2. Negative 2x equals negative 3. So x equals positive 3 halves. That's negative 3 divided by negative 2 is positive 3 halves. And then if you will substitute that to the original equation, that will give you logarithm of 5 to the base 1/3 on both sides of the equation. So correct. So our answer here is x equals 3 halves. Number 4, this involves quadratic equation. 2x squared plus 28 equals x squared plus 11x. Put all of them on the left side. We will have 2x squared minus x squared. That's x squared. 11x will be negative 11x. And then just copy 28 equals 0. What factors of positive 28 will give you a sum of negative 11? That's negative 4 and negative 7. So x equals 4 or x equals 7. If we will substitute that to the original equation, we will satisfy the equation with both the numbers 4 and 7. So we have two answers here, x equals 4 or x equals 7. Okay, if you got 4 in this set of exercises, then congratulations, you learned in the examples. I hope that you continue to learn in the videos here at Fat Math. Let us have more equations, equations that look different. Okay, this time we don't have logarithm anymore on the left side. We have logarithm of x minus 2 to the base 2 equals 4. So what we're going to do if we have this is we just transform this to the exponential form, the equivalent exponential form. So the exponential form of this is 2 raised to 4 equals x minus 2, or we can just write x minus 2 first on the left. So we have x minus 2 equals 2 raised to 4. So The x minus 2 here will be the answer on one side, and then the base here is still the base, and the answer here will be the exponent. So 2 raised to 4 is 2 times 2 times 2 times 2, 16. And then you put negative 2 to the right, that will be positive 2. So x equals positive 18. If you will substitute that to the equation, to the original, you will have 18 minus 2 is 16. Logarithm of 16 to the base 2 is indeed 4. So the answer is x equals 18. Example number 7, number 8. Logarithm of 2x plus 9 to the base 3 equals 3. Transform to exponential form. The exponential form of this is 2x plus 9 equals 3 cubed. 3 cubed is 27. Minus 9, because you put 9 to the right side, that will give you 18. Divide both sides by 2. X equals 9. So x equals 9. If you substitute that, you will have 2 times 9. 18 plus 9. 27. Logarithm of 27 to the base 3 is indeed 3. So correct. Number 9. Example number 9. Logarithm of 3x minus 1 to the base 1/2 equals negative 3. So we have here the exponential form. 3x minus 1 equals 1/2 raised to negative 3. And 1/2 raised to negative 3 is 2 raised to positive 3. That is 8. So 8 plus 1 is 9. Divide both sides by 3. So x equals 3. So 3 times 3 is 9. 9 minus 1 is 8. What should be the exponent of 1/2 to get 8? Negative 3. So correct. So our answer here is positive 3. Number 10. Logarithm of 4x minus 20 equals 2. We don't see any base here, so the base is 10. This is a common logarithm. So the exponential form of this is 4x minus 20 equals 10 squared. 10 squared is 100, so plus 20, that is 120. Divide both sides by 4, you will get x equals 30. So the answer is x equals 30. If x is 30, you will have 4 times 30, that's 120. Minus 20 is 100. Logarithm of 100 is indeed 2. Example number 11. Here we have two logarithms on the left side. So logarithm of 4x to the base 2 minus logarithm of x plus 4 to the base 2 equals 1. So what we're going to do here is we will apply the law of logarithm. We will condense these two logarithms into a single logarithm. So if you have there difference, then you can express that as the logarithm of the quotient. The logarithm of the quotient of 4x and x plus 4. So logarithm of 4x over x plus 4. Okay, that's the law of logarithm. So if it's a sum, then you can express it as a logarithm of a product. But if it's a difference, then you can have the logarithm of the quotient. And then after that, you transform this to exponential form. 4x over x plus 4 equals 2 raised to 1. 2 raised to 1 is 2. And then multiply both sides by x plus 4. So you will have, because that is a rational equation, so you multiply both sides by x plus 4. Multiply this by x plus 4 so that the x plus 4 will cancel. Or you can simply say you cross multiply. You multiply x plus 4 by 2, you will get 2x plus 8. And then put 2x to the left side, you will have 4x minus 2x equals 8. 4x minus 2x equals 2x equals 8. Divide both sides by 2, you will get x equals 4. If x is 4, you will have logarithm of 16 to the base 2. 4 times 4 is 16. So to the base 2 is 4. And then 4 plus 4 is 8. Logarithm of 8 to the base 2 is 3. So 4 minus 3 is indeed 1. So x equals 4 is the solution. Another example, example number 12. Logarithm of x minus 1 to the base 6 minus logarithm of 5x plus 1 to the base 6 equals negative 1. Same process, condense this into logarithm of a quotient. So you will have and then transform to exponential form. So x minus 1 over 5x plus 1 equals 6 raised to negative 1. 6 raised to negative 1 is 1/6. And then you can cross multiply. Multiply 6 by x minus 1 and 5x plus 1 by 1. Okay? Since we have single fractions on the left and the right side, we can just cross multiply. Multiply that and then multiply this one. So x minus 1 times 6 will give you 6x minus 6, and 1 times 5x plus 1 is 5x plus 1. And then this is already a linear equation. Okay, solve the linear equation, you will get x equals 7. If x is 7, you will have 7 minus 1 is 6, so logarithm of 6 to the base 6 is 1. 5 times 7 is 35 plus 1, that's 36. Logarithm of 36 to the base 6 is 2. So 1 minus 2 is indeed negative 1. So this one is correct. So we have x equals 7. Example number 13. We have logarithm of x plus 3 to the base 3 plus, this time plus logarithm of 2x minus 3 to the base 3 equals 4. So if it's the sum of logarithms, you can condense that as a logarithm of a product. Logarithm of the product of x plus 3 and 2x minus 3. Just do some multiplication there. You will get 2x squared plus 6x minus 3x. So that's positive 3x. And then minus 9. Okay, transform to exponential form. So 2x squared plus 3x minus 9 equals 3 raised to 4. 3 raised to 4 is 81. You put that to the left because this is a quadratic equation. That will give you negative 9 minus 81. That is negative 90. And then factor. So factors are 2x plus 15 and x minus 6. So by this time, at grade 11, you should be a master of factoring quadratic trinomials. So factoring quadratic trinomials is a trial and error. So you have to do that. You are going to look for factors of 2x squared. So that will be 2x and x. And then factors of negative 90 so that the middle term will be positive 3 if you will expand. So we get here 2x equals negative 15. So x equals negative 15 over 2. Or x equals 6, and we can substitute both of them. If we will on the original, if we will substitute negative 15 over 2, we will have logarithm of a negative number which is not defined, so we will not have that as the answer. So this one, we will not accept this because that will give you logarithm of a negative number. And for 6 plus 3 is 9, logarithm of 9 to the base 3 is 2. 2 times 6 is 12 minus 3, that's also 9. Logarithm of 9 to the base 3 is 2. So 2 plus 2 is indeed 4. So this x equals 6 is the only answer here. So x equals 6. Another example number 14. Logarithm of x minus 8 to the base 2 plus logarithm of x minus 4 to the base 2 equals 5. We have logarithm of the product of x minus 8 times and x minus 4. If you multiply them, you will get x squared minus 12x plus 32. And then transform to exponential form. X squared minus 12x plus 32 equals 2 raised to 5. 2 raised to 5 is 32. So you will transfer that to the left side. You will get negative 32. 32 minus 32 is 0. So we will be left with x squared minus 12x equals 0. And then factoring that, you will get x times x minus 12 equals 0. So that will give you x equals 0 or x equals 12. If x is equal to 0, we will have 0 minus 8 here. 0 minus 8 is negative 8. Logarithm of negative 8 is not defined. So we cannot have x equals 0 as the answer. How about 12? 12 minus 8 is 4. Logarithm of 4 to the base 2 is 2. 12 minus 4 is 8. Logarithm of 8 to the base 2 is 3. So 2 plus 3 is indeed 5. So correct. So x equals 12 is the only answer in this example. So here we are applying the laws of logarithms, that the sum of the logarithms can be condensed into the logarithm of the product. Example number 15, this time it looks different. So just transform to exponential form and then substitute to the original. So the exponential form of this is x squared equals 25. Extract the square root, you will get x equals positive or negative 5. But a base of negative 5, our x here is a base, and base is restricted to be positive and not equal to 1, so negative 5 is not allowed here. So the only answer is x equals 5. Example number 16, we have logarithm of x squared to the base 3 equals 4. Just transform this into its exponential form. You will get x squared equals 3 raised to 4. 3 raised to 4 is 81. Extract the square root, you will get positive or negative 9. If you will substitute positive 9, you will get 9 squared is 81. Logarithm of 81 to the base 3 is indeed 4, correct? But if x is negative 9, negative 9 squared is still positive 81. And logarithm of 81 to the base 3 is still 4. So both positive 9 and negative 9 are allowed in the equation. So we have two answers here, negative 9 or positive 9. Okay, time for practice. So we have here 5 items for your practice. And some of them will take you a little bit longer, like these numbers 3, 4, and 5. Number 4 and 5 will involve quadratic equations, so you will also factor. Okay, so pause the video and answer the items. A quick shout out to all my incredible subscribers. Thank you for being here and for your amazing support. You're the reason I love doing these videos. If you're new, don't forget to subscribe and join our growing community. To all my regulars, you're the best. Let's keep learning and growing together. Okay, for the answers, I'll just provide you with the answers here, and you go over the process. And if you can't understand why it became like that, you can comment down below for your questions. So this is transforming to exponential form and solving the linear equation. If you substitute, it will satisfy. So the answer is 16. So 5 times 16 is 80 plus 1 is 81. Logarithm of 81 to the base 3 is indeed 4. Number 2, transform to exponential form. You will eventually have linear equation. So x equals 13. If x is 13, 2 times 13 is 26 plus 1, 27. So logarithm of 27 to the base 1/3 is indeed negative 3. Number 3, we will apply here the law of logarithm, that the difference of the logarithms can be condensed into the logarithm of the quotient. So we will have logarithm of x plus 5 over 60 minus 4x to the base 4 equals negative 2. Transform to exponential form, cross multiply, and then you will have negative 1. If x is negative 1, you will have here negative 1 plus 5 is 4. So logarithm of 4 to the base 4 is 1 minus 4 times negative 1 is 4. Negative 4. 60 minus negative 4 is 64. Logarithm of 64 to the base 4 is 3. and 1 minus 3 is indeed negative 2. So we have x equals negative 1. Okay, for the last two items, we have here applying the law of logarithm. The sum of the logarithms can be expressed as the logarithm of the product. Multiply x minus 12 by 2x minus 3, you will get 2x squared plus or minus 24x minus 3x, that's minus 27x, plus 36. Transform to exponential form, and then write the quadratic equation in standard form, and then factor. And you will get negative 3 halves and 15. If x is negative 3 halves, this will be a negative number, so that's not allowed. So negative 3 halves is not an answer here. And then if x is 15, 15 minus 12, that's 3. Logarithm of 3 to the base 3 is 1. 15 times 2 is 30 minus 3 is 27. Logarithm of 27 to the base 3 is 3. And 1 plus 3 is indeed 4. So 15 is okay. And that is the only answer. For number 5, similar process. And eventually you will get x equals 0 or x equals 5. But if x equals 0, this will be 0 minus 4, negative 4. Logarithm of negative 4 is not defined, so x equals 0 is not allowed. If x is 5, you will have 1. Logarithm of 1 to the base 2 is 0. Plus 5 minus 1 is 4. Logarithm of 4 to the base 2 is 2. And 0 plus 2 is indeed 2. Okay, so x equals 5 is the only answer in number 5. I hope that some of you got 5 points, or many of you got 5 points in this set of exercises. If you have questions, you can comment down below. I hope that you learned a lot in this video. Continue supporting this channel, and I hope to see you in other videos. Till next time, goodbye everyone! Thank you for watching. Comment, like, and subscribe. Bye!